All right, so in this video, what we're going to be focusing on is how to find the missing dimension of any 2D shape. Friendly reminder that you know how to find the missing side of a right triangle using the Pythagorean theorem. So what we're going to do now is we're going to be looking at circles and rectangles and triangles, and we're going to be finding missing dimensions. And what I mean by that is we might be trying to find like the missing base or the missing height. We might be trying to find the missing radius or the missing diameter, things like that, okay? Now, the first problem on this page is not an example. And the reason I'm starting with this is because I want you to see how the stuff you are used to doing, like in this problem, how it's different than the new topic that we're learning on this page. So for the first one, we have an equilateral triangle. And so go ahead and sketch one of those on your notes. And remember that in geometry, to show that something's equilateral, you'll usually see these lines right here to let you know those sides are all the same. All right, so we're going to find the area and the perimeter of this thing, and we know that it has a base of 5. So if this bottom part is 5 and it's an equilateral triangle, we know that all of these are 5s. If the height is a 4.3, you can decide for yourself. Some people prefer to label it with a dotted line on the interior, and then they'd put a 4.3 right here. Since it's a little crowded, I think for me personally, I might prefer to actually label it on the outside. I'm just going to show here that from here to here, the height is a 4.3. So you can kind of decide for yourself how you want to label it. And again, I'm just saying here that we have 5s for the bases and all 3 sides. All right, now for the area, we're going to use, if we have our formulas from our formula sheet, we're going to use the half base times height. And for perimeter, since it's an equilateral triangle, that's actually really easy because it's going to be 5 plus 5 plus 5, or 5 times those 3 sides. So the perimeter we already actually know is a 15. We can start with that one. All right, and then half the base times height over here. So we've got half the 5 times the height of 4.3. And then you can just use the calculator for the rest. The way I like to enter this one in the calculator is to just do 5 times 4.3 and then just hit divide by 2 to cut it in half. And we get a 10.75 for the area here, 10.75. It doesn't say anything, so we can put units, square units. 10.75 square units. Now, when you guys are typing these into the Google form, stuff like this, it would be okay to just type in the 10.75 or the 15. If you see questions like this and you have to put into a Google form, it's okay to just type in like the number. I'm not going to expect you to type in the labeling and deal with exponent and stuff like that. Just the number is fine. Now, again, I mentioned that on this page, number 1 is actually what you're used to doing. This is a type of problem that you've seen before where you're just trying to find area and perimeter. You've been given all of the dimensions that you need. Now for the rest of the page, we're actually going to be trying to find a missing dimension because we're going to be given the total area or perimeter or something like that. So for number 2, I want to know what's the radius of a circle if I tell you that the area is a 50.24. Now I know that I have my little tools here on the computer, but just try to sketch a circle for yourself in your notes. It doesn't have to be perfect. And we're trying to find the missing radius, okay? So from here to here, that's what I don't know. Now we know the formula for area of a circle is pi r squared. And we're going to be using now the skills that we learned in Unit 4, solving equations, to find this missing radius. All right, now we know the the area is a 50.24. So I'm actually going to set the equation equal to 50.24. I know pi is 3.14. And then I don't know the radius of the circle. Now what I'm going to do is I'm actually just going to take r squared and I'm going to cover it up with a big fat question mark. And anytime we have a number times an unknown, so 3.14 times this unknown, we know to solve, we just divide both sides by the coefficient. Now on your notes, I think there should be enough space where you're not getting caught in between all the wording. So I'm just going to actually remove that for right now, just so I'm not getting like smushed here. So all I'm doing is dividing both sides by the 3.14 because I know that 3.14 times this unknown is the 50.24. So if I divide both sides by pi, I can cross it out, and then what's left over here is my question mark, which happens to be the r squared. So using a calculator, we can simply do 50.24, the area, just divide it by 3.14, and we know that this is now r squared. 16 equals r squared. Well, if some number squared is 16, I can simply take the square root and now tell ourselves that the radius has to be a 4. So we just found the radius. Okay, we just found the radius is a 4. We had the total area. I plugged it in. I divided the area by pi to get r squared by itself. Then I took the square root. And now I'm actually going to bring those notes back. There they go. And actually, if I do this, I have a little trick I can do. Let me just group this all together, and I can kind of shrink it down. Now let's see if those notes kind of fit. Yeah, area, we had the area highlighted up here. There we go. Now that kind of fits in between. Okay. All right, so for number 3 then, I want to know the circumference of this circle above. And basically, what you guys need to see the connection is, if I give you the area of a circle, which I did up here, if I give you the area of a circle, you should be able to tell me the circumference. First, you will need to find the radius like we just did, but then if I want to know the circumference, it's simply 2 pi r. And I just found the radius, so 2 times the radius is 8, 2 times 4 is 8, so then it's going to be an 8 pi. My circumference here would be 8 pi. So 8 times 3.14 is 25.12. All right, 25.12 inches. So friendly reminder, it is fair game that if I give you the area of a circle, you can use that to turn around and tell me the circumference. The one step that's in between though is that you would need to find the radius like we did here. All right, now we're on number 4. We're going to find the base of a triangle if the area is 64 square centimeters and we know that the height is 8. Now, one thing I want to mention is if I were to say, hey, just draw a triangle, we have lots of different triangles we could draw. We've seen stuff that is acute. We've seen stuff that's obtuse. We've seen stuff that's right. We've seen lots of different ones. We've even seen ones that look like this. And I can kind of connect the dots here, or connect the edges, I should say. Now, we have no way of knowing which type of triangle it is. We have no way of knowing which one it is. So it doesn't matter actually which one we choose to draw in our notes. For whatever reason, I kind of want to just delete this one. I don't want to use the right one just because we've done a ton with right triangles lately. So one of these two, it doesn't matter to me which one of these we use actually. But it might make sense afterwards if we find, like once we find the base, we might be able to see which one makes more sense just looking at the actual dimensions. So for right now, let's just pretend again we don't know the base for each of these. We'll kind of have to pick and choose which one at the end makes more sense. The height is supposed to be an 8. So from here to here is an 8. Or potentially, you know, if we were to draw this one from here to here is an 8. Now the formula for a triangle for the area is half base times height. And for this one, again, we're given the total area. So now I'm going to set the equation equal to the 64. And it's going to be half, we don't know the base. And then the height here we just said was the 8. Now, a lot like the old unit where we had the I equals PRT, you might remember that sometimes we were trying to find this missing R. And to do that, we multiplied the P and the T together, kind of like right here, half of 8 is 4. So really my equation is a 4b. So if I divide both sides by 4, here 64 divided by 4, I get base. I get what b is. The base has to be a 16. So I'm going to replace here in the pictures that this has to be a 16. Now when we look at the picture, which one actually makes more sense? If you look at these two, Doesn't the blue number have to be a longer dimension than the red number? So I think we can decide that this triangle makes more sense. The base is a 16, the height is an 8. So here it looks kind of like the base is twice the height. So this is the more realistic triangle. And the base was a 16. All right, for number 5, we're trying to find the diameter of a circle given its area. So once again, I know I have a nice little tool up here, but just try best you can to draw a circle. And I'm also going to click and drag area down here as pi r squared. So I'm just going to bring that. You can write that down in your notes. Now, when we do this, we're going to find the radius, which is the distance halfway across. And then we'll just simply double that to get the diameter to go all the way across. All right, so we're going to set the equation equal to the given total to find the missing dimension. So here the area is 28.26. We know pi is 3.14. And remember, I don't know what r is, so I can divide both sides by 3.14 to get r squared. All right, this cancels out, and you can use the calculator to do the 28.26 divided by pi, and that's going to be a 9. So on this side we get 9, and that's what r squared is. Well, if r squared gives you 9, the square root 3 must be r. So we know that this side is a 3. Now we're trying to find the diameter, which is all the way across. So 3 plus 3, the diameter here would be a 6. All right. Now for the next one, I really like this question. This year, we're going to have to do some guessing and checking for it. Next year, you're actually going to learn in algebra how to straight up get the answer without guessing and checking. We have a postcard, so I'm just going to kind of sketch a postcard. I don't know the dimensions, but I know the distance around it is 22. I also know the area is a 28. So we want to know what are the length and width, what are the dimensions of this postcard. So the first thing I want to point out is perimeter. We have a formula for that. It's twice the length plus twice the width. Now we're going to use the given perimeter of 22. Check this out. I've got 22 is twice the length plus twice the width. And I know my handwriting is a little sloppy there. But if I say twice the length and then I do twice the width, can't I just divide this side by the 2 and divide this side by the 2 and say that just one of my length plus width, that just this plus this, then would be an 11? I sure can. So this side and this side is an 11. And then of course, if I were to double it, that's how I'd go all the way around to get the 22. But the thing I care about here is the fact that just this side plus this side is an 11. Because now what I'm going to do is think about all the possible dimensions that can multiply to give me a 28. For example, if I did 1 times 28, that would be an area of 28. But if I put a 28 here and a 1 here, that doesn't add up to the 11. So I know that's not going to be the area dimension that would give me this perimeter. So it's not going to be the 28 and the 1. Now I also know that I could do a 2 times a 14. So if I put a 14 here, if I do 14 and then a 2, well, already that's going to be a 16. So that would be a 32 all the way around. So that's too much. So we don't want that. Now again, another multiplication set that gives me 28 is now if I do 4 times 7. 4 times 7 gives me an area of 28. So this could be a 7 here and this could be a 4. And now look, I found a dimension. The 4 plus the 7 gives me the 11. So that's what I meant by number 6, that right now you just have to list out all the possible dimensions to give you the area, and then ask yourself, of these over here, which add up to give you the perimeter? And right here, this was the set that added up to give me the 11. So I had to guess and check. And next year, like I said, you will actually learn how to straight up be able to tell me that it's a 4x7 without the process of guessing and checking. But I'll let the 8th grade teachers do their job there for algebra and teach you that. But here we can see the dimensions of the postcard would be a 4x7, the 4x7. And now last but not least, we want to know what is the height of a triangle that has a base length of 9 and a hypotenuse length of 11. So what is the height of a triangle with a base length and a hypotenuse length? Now hypotenuse is in a right triangle. So I'm just going to sketch a right triangle. And we are told here that the base is a 9, the hypotenuse is an 11. Now the reason I put this on this page was because I want you guys to not forget about the Pythagorean theorem. We have a squared plus b squared equals c squared. And I know in my picture it kind of looks like an a, but really that's a 9. I might drop this down a little bit more just so you guys can remember that's the 9 from right here. So basically we're saying that 9 squared plus this thing over here, which I don't know, so b squared, equals the 11 squared. And I didn't want you guys to forget that when you have the hypotenuse, you're going to do the c squared minus the other leg squared. So we're about to do 121 minus 81. 121 minus 81. 121 minus 81. And that gives us a 40. So b squared is 40. Now 40 is not a perfect square, so we're going to get a decimal here when we take this. You might remember also that 36 is a perfect square close by, and 49 is a perfect square close by. So this is going to be 6 point something. It'll be 6 point something when we take the square root. And there it is. It's going to be a 6.3. So b here would be a 6.3. And it doesn't matter if I called it A or B when I labeled the picture, it doesn't matter because it's commutative, but I now know that this is a 6.3. And when I look at my picture, do you see how I have my picture, how I sketched it to begin with? It's okay that I now come through and say, all right, I should put the 9 over here. That looks a little weird because I extended that. So I can put the 9 over here and say, okay, the 6.3 is here, and now it makes a little bit more sense, because you can see this side is shorter and that one's a little bit taller. So this is now actually the triangle drawn in a way that makes sense. And it's okay to make those changes once you find the dimensions, to go through and label it in a way that makes sense. But the height here of the triangle was a 6.3. And even though obviously we can see here the way it was asked and drawn, it didn't quite, like, the dimensions can be switched around, and that's okay. If I want it to match up with the problem, then what I should do is say, so the height was the 6.3. So really what I should be doing is this. I can let the base stay the 9 and let it be a little bit longer. The height should be a little bit shorter. And then here's the 11. And now I'm actually I can erase this thing up here. Now it really makes sense. Now everything totally lines up. And that concludes this video. Thank you for watching.